directory. Click Finish, and the module is loaded into Eclipse. There's lots of files and directories here, all of which are discussed in detail in the module development wiki guides. Today we're only going to discuss the necessary changes for creating a module that returns additional sensor data from Android. Let's open up the source directory in our project and find the testingmodule.java file. In here we see the basic layout for module level code. Notice the crawl annotations throughout the class definition. These annotations are how modules, properties, and methods are exposed to Titanium's JavaScript API via your native module. So we have this default module. What do we do with it? Where can we get examples of how to add functionality to it? Fortunately for us, the open source Titanium mobile SDK has loads of them. For those unaware, the core JavaScript API for Titanium is effectively just a series of native modules, built in this same fashion, that have been integrated into the SDK. Let's go out to GitHub and check out the existing accelerometer module in the SDK. In the Titanium mobile project, in the Android modules section, we see a listing of all the modules exposed by the core Titanium JavaScript API. If we click through to the source code for the module, we find a relatively small, concise blueprint for registering sensor events and then sending them back through the JavaScript API. Don't worry if you don't understand all or any of the code at this point. The important lesson here is that when you do decide to dive into native module development, the Titanium mobile SDK itself is a treasure trove of examples written by Appcelerator's platform engineers. Let's go back to Eclipse and take a look at the module I've already created for this experiment, basing it largely on the existing accelerometer module for Android. At the very beginning of the class definition, you'll notice that this module, like the SDK's accelerometer, implements Sensor Event Listener. Implementing this class is what allows us to receive native sensor events from Android devices. The majority of the variables created here are for three-dimensional calculations based on the accelerometer and magnetic field values we receive, and are used a little later in the code. We're still using the default module constructor. No changes are made here. Below it we see the methods for both adding and removing event listeners. We override these functions so that we can add more control over how and when they are registered. The onAccuracyChanged function is not used by our module, and it is given a default empty implementation. Finally, we arrive at the onSensorChanged function. This is the function that will be called whenever Android receives a sensor event for which we've registered. The first thing we do is identify which sensor sent the event, then store its values for later use. We do this because we need both the current accelerometer and magnetic field values to perform the upcoming 3D transformations.